Dear students, in today's class we will solve three problems based on mesh analysis. Now here is second example. Calculate power dissipated by 1 ohm resistance in the circuit shown in figure below. So here is the circuit, and in this circuit you can see 1 ohm resistor here, and here it is 6 volt source. Now we will redraw the circuit and then mark all the mesh currents in clockwise direction, and also we will show the direction of voltage rise. Now here is the redrawn circuit with mesh currents I1, I2 and I3 all marked in clockwise direction. Six volt source has voltage rise direction from right to left. Before we apply KVL and write the three equations for the given problem here, we will refer to the previous problem solution and see how easily we can write the three equations by applying KVL in this problem. If I look at mesh 1 and equation 1, drops in mesh 1 are 3I1 and minus I2. 3I1 is obtained by adding all the resistors in mesh 1 and multiplying with I1. That is 2 plus 1, 3, 3 into I1. Whereas minus I2 is obtained by multiplying common resistor 1 ohm with minus I2, because I2 is flowing in the common branch in the opposite direction to I1. So this principle we can use now in writing equation for first mesh by applying KVL in the given problem. Applying KVL to mesh 1, voltage rise in first mesh is 0 because there are no voltage sources. So 0 equal to. Next, what we have to do? Add all the resistors in first mesh. 6 plus 1, 7, 7 plus 5, 12, 12 into I1. So I have written here 12 into I1 minus common resistance between mesh 1 and mesh 2 into mesh 2 current I2. Common resistance between mesh 1 and 2 is 1 ohm and mesh 2 current is I2, that is, we have to write here 1 I2. Common resistor between mesh 1 and mesh 3 is 5 ohm. So drop in 5 ohm due to I3, we have to write as minus 5i3 minus 5i3. It is very simple to write equations if you follow this method. I will take mesh 2. Voltage rise in mesh 2. There is no voltage source. So voltage rise is 0. Voltage drop in mesh 2 due to I2 is to be calculated as sum of resistors in mesh 2 multiplied by I2. So 1 plus 3 plus 4, 8 into I2, that is 8 I2. This will be positive term. Voltage drop in resistor common to mesh 1 and mesh 2, that is voltage drop in 1 ohm resistor due to current I1 will be equal to I1 into 1 ohm with negative sign. Minus 1 into I1 is minus I1 only. Minus drop in resistor common to second mesh and third mesh, that is 4 ohm, is equal to 4 into I3 with negative sign. Now let us call this as second equation. Now we will consider mesh 3 and apply KVL to it. Voltage rise in mesh 3. There is only one voltage source. Voltage rise direction of that source and the current direction in mesh 3 are same. So voltage rise will be positive. I will write here 6 equal to. Next we have to write voltage drop in mesh 3 due to I3. 5 plus 4 plus 2, 11 I3, and it will be positive term. Next we have to write voltage drop in resistor common to third mesh and first mesh due to first mesh current, that is minus 5i1. Voltage drop in common resistor to mesh 2 and mesh 3, that is minus 4 into I2. So minus 5i1 minus 4i2. Last term is positive term. Let us call it as third equation. So just looking at these three equations, you will understand for which mesh we are writing equation drop due to that mesh current will be positive and drop due to other mesh currents will be negative. Now we have to solve these three equations using calculator. So A1 is 12, B1 is -1, C1 is -5, D1 is 0, A2 is -1, B2 is 8, C2 is -4, D2 is 0, A3 is -5, B3 is -4, C3 is 11 and D3 is 6. Switch on calculator. Press mode button until you get EQN. You got EQN. Now select EQN by pressing 1. It will ask for number of unknowns. Number of unknowns is 3. So press 3. Now it will ask for A1, B1, C1, D1 and so on. You go on substituting the values. A1 is 12. Press equal to. B1 is -1, press equal to. C1 is -5, press equal to. D1 is 0, press equal to. A2 is -1, press equal to. B2 is +8, press equal to. C2 is -4, press equal to. D2 is 0, press equal to. A3 is -5, press equal to. B3 is -4, press equal to. C3 is 11, press equal to. D3 is 6, press equal to and get all the three mesh currents I1, I2, I3 as X, Y, Z. I1 is 0.430. In this problem what I will do is I will take 3 digits and then calculate remaining quantities. We'll see how the accuracy improves. 0.430 is I1 now. I1 equal to 0.430 amperes. To get I2, press equal to button once again. I2 is 0.518. And I3 is equal to 0.929. We have to calculate power dissipated by 1 ohm resistor. For that we need to calculate first the current flowing through 1 ohm resistor. So right here current flowing through 1 ohm resistor is equal to, referring to the circuit, current through 1 ohm is difference of two currents I1 and I2. Better you subtract current having smaller value from current having lower value. I2 is having higher value, I1 is having lower value. So I will write here I2 minus I1. resultant current, that is difference current, will be flowing in the direction of I2 because I2 is having larger value. .518 minus 0.430, 0.088 amperes. If you want, you can write here. In the direction of I2. If you calculate this current as I1 minus I2, then you will get here negative value. Then you will have to write in the direction opposite to the direction of I1. Next we will calculate power dissipated in 1 ohm resistor is equal to current through 1 ohm resistor squared, that is I2 minus I1 squared, into 1 ohm, that is 0.088 squared into 1. On simplification we get it as 7.744 milliwatt. To know the accuracy of our answers, we will substitute these three currents in any one of the equation and see what happens. I will take first equation for substitution purpose. 12 into 0.430 minus I2. I2 is 0.518 minus 5 into I3. So 5 into 0.929 equal to, we get it as minus 3 millivolts. Minus 3 millivolts is very close to 0. On RHS we are having here 0 only. Now we will take third problem. For the circuit shown in figure below, obtain the voltage between X and Y. So point X is here and Y is here. Between these two, what is the voltage that we have to calculate? First we will redraw the circuit and then we will find the two mesh currents here. So here is the redrawn circuit. Now I will mark here mesh currents. Because independent meshes are here, I will assume that current flows in the direction of voltage rise only. Applying KVL to mesh 1 and 2, we will find out what is I1 and what is I2. So in mesh 1 we are having voltage rise equal to 2 volt. So 2 volt is equal to I1 into 3 plus I1 into 2, that is I1 into 5. applying KVL to mesh 1, 2 is equal to 3i1 plus 2i1, that is 2 equal to 5i1, and hence i1 is equal to 2 by 5, that is equal to 0.4 ampere. Now applying KVL to mesh 2, voltage rise is 4 volt, voltage drops are 2 into I2 plus 1 into I2 plus 5 into I2. So 4 is equal to 2 I2 plus 1 I2 plus 5 I2. That is 4 is equal to 8 I2, or I2 is equal to 4 by 8, that is equal to 0.5 ampere. Now we will select part of the circuit between points X and Y. Here we are having X and here we are having Y. So 3 ohm, 4 volt and 2 ohm. This part of the circuit we will draw separately. Current through 3 ohm is only I1 and that is flowing upward. Current through 2 ohm is only I2 and that is flowing downward. So I1, I2. I1 is how much? I1 is 0.4 ampere and I2 is how much? 0.5 ampere. So I1 is 0.4 A and I2 is 0.5 A. We will calculate voltage drop in 3 ohm resistor and 2 ohm resistor. Is equal to 3 into I1, that is 3 into 0.4, which is 1.2 volt. Voltage drop in 2 ohm resistor is equal to 2 into I2, that is equal to 2 into 0.5 and that is equal to 1 volt. Now we will show the voltage drop polarity. Where the current enters, there you show voltage polarity as positive, and where the current leaves, there you show the voltage drop polarity as negative. So plus here and minus here. Now we will replace the resistors here, that is 3 ohm resistor and 2 ohm resistor, by voltage sources having magnitude equal to voltage drop in 3 ohm and 2 ohm respectively, with the polarity shown here. Point X, drop in 3 ohm resistor is 1.2 volt And then here we are having 4-volt source. This is Y here, and drop in 2 ohm resistor is 1 volt. Now we will stretch this part of the circuit XY to make it straight. Then it appears so X is here now and Y is here. This is 1.2 volt, this is 4 volt, and this is 1 volt. Now mark the voltage rise directions. Towards right, and this is towards left. Now voltage across X and Y is sum of voltage sources acting in one direction minus sum of voltage sources acting in other direction. That is, I will show the two voltage sources acting in one direction as one voltage source with a magnitude of 4 plus 1.2, that is 5.2 volt, and the magnitude of other voltage source which is acting in opposite direction is 1 volt. Now we have to get the resultant voltage. Between X and Y as 5.2 minus 1, because these two sources are acting in opposite direction. That becomes 4.2 volt. Therefore, voltage across X and Y terminals minus 4.2 volt, as Y terminal potential is higher than X terminal potential. Now here is the fourth problem. Find the currents in the various branches of the given network shown in figure below. So here it is the given network, and here incoming currents at certain nodes or junctions and outgoing currents are given along with the branch resistance values. For example, AB is having 0.02 ohm, AF is having 0.01 ohm, and so on. Now we have to find how much current flows through AB, how much current flows through BC, and so on up to AF. First we will redraw the circuit and then we will make use of KCL and KVL to solve this problem. Now here is the redrawn circuit. We will assume current through branch AB as I1. So right here, assume current through branch AB as I1. Now what will be the current in branch BC? By applying KCL at node B, we get current through branch BC as incoming current minus outgoing current, that is I1 minus 80 ampere. Current through branch DC will be sum of incoming currents, that is I1 minus 80 plus 90 equal to I1 plus 10. I1 minus 80 plus 90. How much it will be? It will be I1 plus 10. So we get current here as I1 plus 10 ampere. Next, current in branch DE is equal to incoming current minus outgoing current, I1 plus 10 minus 150. That will be I1 minus 140. Current in branch EF is sum of incoming currents, because both currents are incoming currents here. I1 minus 140 plus 120, that will become I1 minus 20 ampere. Current through branch FA is I1 minus 20 minus 80, that will become I1 minus 100 ampere. So at node A, if we again apply KCL, in branch AB I should get I1 current. I1 minus 100 is incoming current, 100 ampere is incoming current, so I1 minus 100 plus 100 will become I1. Now we will apply KVL to this mesh. There is no voltage source in this mesh, so voltage rise is 0. Applying KVL to the mesh, what I should get here? Sum of drops in branch AB, BC, CD, DE, EF and FA equal to voltage rise, that is equal to 0. So 0 is equal to I1 into 0.02 plus I1 minus 80 into 0.02 plus I1 plus 10 into 0.03 plus I1 minus 140 into 0.02 plus I1 minus 20 into 0.01 plus I1 minus 100 into 0.01. Now we have to simplify this. On simplification we get 0.11 I1 minus 5.3 equal to 0. Now we can get the value of I1. I1 is equal to 5.3 by 0.11, that is equal to 48.18 ampere. Now we can find current in all the branches. Current through branches AB to FA, that is IAB equal to I1, that is equal to 48.18 ampere, IBC equal to I1 minus 80, that is 48.18 minus 80, that is equal to minus 31.82 ampere, which means the direction of current is opposite to what we have assumed in branch BC. ICD is I1 plus 10, that is 48.18 plus 10 equal to 58.18 ampere. IDE is equal to I1 minus 140 ampere, that is 48.18 minus 140 equal to 91.82 with minus sign. And IEF equal to I1 minus 20, that is equal to 48.18 minus 20 equal to 28.18 ampere. IFA equal to I1 minus 100, that is 48.18 minus 100 equal to 51.82 with minus sign. Wherever we have got negative signs, there we shall have to reverse the direction of current to make the sign positive. Dear students, I will stop the class here and continue in next class with second chapter. Thank you.